minus, no, you have 8, you have only 8. Right? So then you've got enough information, you've got 3 equations and 3 unknowns, you work it out, right? You get A is 3, of course, B is -1, and C is 5. Okay. And so right, that tells you what these guys are, right? This is 3, this is -1, and this is 5. That is if you use the first method. If you use the second method, probably the second method is easier, right? So if you evaluate, so method 1, and method 2, if you evaluate at x equals, say, 1, right, what do you get? You get 5 equals C. Right? That's great. Right? That gives it to you immediately. At x equals 0, you get 3 equals 8. Right? And then you could use your first this bit to figure out that right, that b is -1. Right? So you get your partial fraction, you get your partial fraction decomposition, and if somebody wants you to integrate it, well, this is easy integration, right? This sort of thing is trivial to integrate. Okay, I've gone past the time, but let me just put up the form, and I'll let you figure out the coefficients on your own. Right? If I have something like this, what's the form going to look like? Well, I've got this linear term, so it'll be a over some constant over that linear term. I have an irreducible quadratic term, so I'm going to have a bx plus c over that quadratic term. And that's the end. If this were some higher power, right, if this were, say, squared, then I would have x squared, I would also have this sort of term involved. Okay, and then you just play the same game of, comparing coefficients or clever substitution. Okay. Okay, that's it for today.